Thursday. If everybody would be so kind to sign it. Fingerprint themselves.
So no blood today.
Excuse me?
No blood spilled on the
No blood. This is a copy of today's notes. Did anybody miss the last lecture on how to read a scientific research paper? If you did, you can find that lecture on YouTube. How to read a scientific research paper. It's turning out so far to be a pretty popular video. There are lots of people watching it. Last time I checked, there were more than 20 countries looking at that video. So it's I think it's going to be popular in the long term. If anybody did miss last time, I have extra copies of the notes. I have extra copies of the first lecture too, which is also on YouTube. There are some extra copies. Are there any questions before we get started on this very exciting and challenging topic? Okay, so this is a very exciting topic, by the way. This is really, really exciting. It's hard to overstate how exciting this is. And one of the reasons it's so exciting is because it's such a big challenge. And before I go on, this lecture really fits together with the previous lecture. They're really together. They're a cohesive unit. So it makes sense to connect them together, right? They need each other. So how many people here are trying to write a literature survey? Good, perfect. There are people trying to write literature surveys all over the place. Always working very hard during the lectures. So this is an overview of the topics we're going to talk about. So it's divided kind of into partitions. So we have the motivation. I think we all know we're all highly motivated but we're going to review it anyway. We're going to look at what the challenges are involved in writing a literature survey, and then we're going to talk about different aspects of the survey: scope, search methodology, contributions, field challenges, classifications, examples from the different subjects in College of Science, and metadata and subsections. And you'll notice this partition is about the preparation, what you do before you start writing your survey, and this is about the actual writing process. And some of these actually are included in both. Scope is preparation and writing, and search methodology is about preparation and writing. So that's why it has and writing. But you can think of sort of the first part being all about the preparation, and then this bottom half being a focus with a special focus on the writing. So why are we here? Why are we talking about this really cool topic? So if we're writing a master's thesis or a PhD thesis, we need a literature survey. And the goal of the literature survey is to find out what has been done already, right? So a new research project often starts with a literature review. We want to determine solved and unsolved problems. That's one of the goals of the literature review, right? And we want to work on unsolved problems as opposed to working on solved problems. Has anybody here ever worked on a solved problem before? I have, yeah. And then in the middle of your work, you discover, oh, it's already been solved. It happens all the time. So a challenge is that a very large, and I've got large volume in boldface italicized font, previous literature exists. And keeping up with this literature explosion is identified as one of the top challenges in any field. And it's not getting any better, it's just getting more and more difficult with the passage of time so far. Maybe that trend will reverse someday, somehow, but right now it's just getting more and more difficult. So this is true, this is a ubiquitous truth. How do we manage this massive complexity, and how can we determine the unsolved problems to work on? This is part of the inspiration for why we're here and what we're talking about today. And some of the key questions we'd like to address when conducting a literature survey. What has been published so far? How have certain studies built on previous ones? Right? How is previously related literature connected? Are there any controversies, debate, or contradictions, unresolved conflicts, for example, or disagreements? Have pathways of future research already been suggested? So this is one of the key questions that you want to keep in mind when you're doing your literature survey and your literature search. Because the answer to this question is yes. Yes. Pathways of future research have already been suggested, and they're already there in the research papers. They're always at the end of every research paper, right? Future work. How will your survey make a unique contribution to the literature, right? Your survey can make a contribution, right? It's a big opportunity, actually, to make a contribution to science, to write the literature survey, because you can publish the literature survey. And literature surveys are very valuable for other people, right? And they're the most highly cited papers, generally speaking. Literature surveys are the most highly cited papers in general. So if you manage to publish a survey paper, chances are it will be your most highly cited paper. Anybody remember the physics paper? The most highly cited physics paper is a literature survey. Quite an extreme literature survey, but it is a literature survey. Which methodologies have researchers used and which appear to be best? Who are some of the key researchers or leaders in your field? Very good to know. And you can gather that information in your literature survey. And how does your topic fit into the larger context of previous work? These are all questions that we want our survey to address, and we want to keep our radar scanning for the answers, right? And we're going to talk about all these things today. These are all questions we're going to address today, right? Sounds very exciting, doesn't it? It's a lot of challenges to address with the literature survey. This is a non-trivial job. This is very challenging. To do a good literature survey is very challenging, right? To do a bad literature survey is not that very challenging, but to do a good one is very challenging, right? Can anybody vouch for that in the audience? I know there are some people that can vouch for that. So one of the goals is to obtain an overview of the literature, right? To find solved and unsolved problems, right? Another goal, if you're feeling very ambitious, and we are very ambitious in this room, right? The Swansea University is very ambitious. The College of Science is very ambitious. We want to publish our literature surveys. That's the standard we're trying to reach. We want to be leaders, we want to be contributors, we want to publish our literature surveys, and that's what this lecture has that goal in mind, to be at such a standard as to publish the literature survey, right? And this is going to get you on the right direction to achieving that goal. Some people don't even know that they can publish their literature surveys, right? So this lecture is based on previous experience in reading and writing surveys. Thank you very much. So this is, so far I've been working on 10 surveys. So I've lost track actually of how many. I tried to write them down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 published so far, and I have 5 work in progress surveys. Not to mention the surveys that I've read and reviewed, right? I don't have a count of those, but that's probably 100, something like that. And PhD supervision experience, right? So literature surveys are difficult to write and pose a lot of challenges. I think everybody understands that point by now. So what are the challenges? The challenges are the volume of literature that's already been published. That's at the top, right? Challenge number 1. Choosing a starting point is challenge number 2. Well, guess what? You solved this problem by coming here today. This is a great starting point, this lecture. Right? Well, meeting with your supervisor is a good starting point too. But this lecture is another great starting point. Deciding on a topic. Sound familiar to everybody? This is also called choosing the scope of your survey. What goes in the survey and what doesn't go in the survey. Which literature is included and which literature is not included. Very critical discussion, very critical challenge. How to perform the search, right? We need some sort of search methodology. We need a way to navigate the individual papers, right? When we have a stack of 100 of them, for example, how do we navigate each individual paper? That challenge is addressed in the previous lecture. So that's what the previous lecture is about, right? So check that out if you... And it's archived so you can watch it again, because these topics are challenging and you won't always understand everything the first time you see it. So now you can rewatch it in 6 months' time. And if you do rewatch it in 6 months' time, it will look different. The whole thing, you'll have had lots of practice trying to read research papers, and then you'll see that video again with a new understanding of having tried it so many times, and suddenly it will make so much more sense. Deriving a classification of the literature, that might not make sense to everybody right now, so that's something we're talking about today. And determining unsolved problems. These are really together, right? These two fit together very closely. In order to determine unsolved problems, it's based on deriving one way to do that is to derive a classification of the literature. Right, so these are the things we're going to talk about today. So let's jump in. Scope, choosing a topic. And this fits in the preparation and writing stage, right? So deciding on the scope of a literature survey is very challenging. It's almost like you have a spotlight, right? You can think of the whole world as a spotlight, or the whole world of literature. It's like we live in this space of literature and research papers, and you can think of it as a dark space that you can't see, right? Because it is a space that you can't see. And all you have is a spotlight. So you can turn on your spotlight, and when you shine it, you see a collection of research papers, right? You can widen the scope of your light so that it includes more research papers in the dark world of research, right? You can change the direction, any direction, and you can narrow the scope, right, to get it to be very sort of, narrow and specific, and you can point it anywhere, right? So the analogy is very appropriate, and that's exactly what we're talking about. So step one, discuss a direction with your supervisor, right? Your supervisor has years and years and years of experience. So they've been trying to keep up with the literature for a long time. Some supervisors have been studying literature for 30 years, right? So if you don't discuss the scope with your supervisor, that's a big mistake, right? And all your supervisors are struggling with the same problem, but they're going to have good ideas about the direction to go in. So they're going to make recommendations about directions to go in, right? So make sure you discuss that part with your supervisor. Another important point is you choose a scope that you think is too narrow to start with. So you want your light, the periscope that you're using to have a very narrow scope, or a narrower scope than you think is necessary. It's much easier to choose a scope that's too wide or too broad by accident, right? That's usually what happens. You say, I want to do a literature survey on, I remember during my PhD, the literature survey started out as a literature survey on the topic of flow visualization. But quickly, we didn't know it at the time, but the scope was too wide. How did we discover that the scope was too wide? Because we kept finding paper after paper after paper after paper that fit inside the scope. And when too many papers fit inside the scope, then the scope is too wide. It becomes unmanageable, right? You've chosen a direction that's too broad, right? This is a very, very common pitfall. And it's much easier, if you think you've chosen something too narrow, don't worry about it. Just stick with your narrow topic. And then when you've finished your search, if you've only found 10 papers related to your topic, then you can decide, it's too narrow. And you can make it a little bit broader. But choosing something too wide is the more common. So do a preliminary search. How many papers are you finding on your chosen topic, right? Without reading them. You just looking at the titles, downloading them, looking at the abstracts, and trying to answer the question true or false. Does this fit in my survey scope? Yes or no? Just collect them. If you find out there are too many, your scope is too wide. How many is too many? My personal opinion, you'll get different opinions from everybody, but I would aim for something like 50 papers per student supervisor pair, right? This is a rough guideline. You want to aim for something like 20 to 25, and then in the end, you have something like 50 papers in your survey, right? Per student supervisor pair. So if it's just you and your supervisor and nobody else, you would aim for roughly a scope of 50-ish papers, right? That's very rough, plus or minus, 10 or 20, right? If you're collecting and you find you've got 100 papers easily in your scope, it's too much, right? You found a scope that's unmanageable. And so that's how I discovered that the first scope of my first survey was too big, right? I was discovering too many papers on the topic. And if you noticed, a lot of surveys include 5 authors, 6 authors. That physics survey that we talked about last time and we mentioned today, it had 100 authors, right? Serious business. So I didn't do the maths to find out how many papers per pair it was, but that's a special kind of survey. Here's another great thing. Don't forget to search for existing surveys. So maybe you have a literature review topic, but maybe there are already surveys published on that topic. Happens all the time. don't forget to look for the existing surveys. Chances are, nowadays, there's already a literature survey that is related to your topic. So your literature survey should be something different. It can't be the same. Well, you don't want it to be the exact same thing. And then you look inside this literature survey to see how they did it and what the solved and unsolved problems are. What do they recommend? What do they see as solved and unsolved problems? And for the writing, when you start writing your survey, you include a description of your survey scope in the introduction. The introduction section has a subsection called survey scope, where you describe what is included, what are the topics that are included, what are the papers that are included, where do you draw the line between what you included and what you leave out. And you also mention what you leave out. So you say, oh, this is beyond the scope of this literature survey. Right? Any questions so far on scope? Very, very critical. So when we are having meetings about surveys, we spend a lot of time talking about this. I think the majority of the time is we're talking about the scope in the majority. That and the classification, those two topics are what we're talking about for the most of the time, I think. Search methodology, how do you find what you want to find? Right? Here are just some guidelines as your starting point. So every field and every academic, right, like your supervisor or supervisors actually, you have multiple supervisors, have their favorite digital libraries. They know about the digital libraries that they think you should be looking in. Right? Ask them what they think their favorite digital libraries are. There are lots and lots of digital libraries. Nobody knows about all of the digital libraries. Right? Somebody in geography is not going to know about the mathematics digital libraries necessarily, and so on. And even within a specific discipline like computer science, there won't be a consensus about the most important digital libraries. Right? So different academics will have their different digital libraries that they go to for the most important literature sources. So you find the relevant digital libraries. Just as two examples, in computer science, there's an ACM digital library and there's an IEEE Explore digital library, and those are the two most important in computer science. But that's not true about all the others. Your discipline will have its own corresponding digital libraries, and you have to find out. You have to ask your supervisor. Don't rely only on Google Scholar. Right? Google Scholar is not going to have all the papers that you need. Right? A lot of people just rely on Google Scholar, but it's not going to have everything. It's good to include and to consider and look for papers using Google Scholar, but it's not the end of the story. There's another very popular one called ArchiveX, very popular for physics, mathematics, computer science, and computational biology. Right? But that's just one, right? And have a look in the related work section and references section of important papers and find out where those papers are archived, right? Your supervisor will sometimes give you important papers to read, right? And in those important papers, there's a list of references. Find out where those papers are archived. Which digital libraries are they in, right? And that will give you some great. And you include a description of your search methodology. Can you guys read that, actually? This bottom one? Yeah. You include a description of your search methodology in your introduction section. So you're writing the introduction of your literature survey, and there is a subsection called search methodology. Where did you look? What were your primary sources, digital library sources, for example? What were your secondary digital library sources? How did you conduct your search? What tools did you actually use, right? Very important. Contributions. So in your literature survey, this is actually the writing bit where we start to actually write things down. In the introduction, you want to formulate some list of contributions that your literature survey makes, right? If you're trying to publish it, you always try to formulate some contributions. And we talked about this in depth last lecture, what contributions are, right? Remember that discussion of concept versus implementation, right? For example, these are just some very, very generic examples, but it gets you thinking in the right direction. That you're writing the first literature survey of its kind on a chosen topic, right? Hopefully that's what you're doing. There's something new about your literature survey. There's something new about the scope that nobody else has done before, right? You choose that very carefully together with your supervisor. You introduce a novel classification of the literature, and this is something we're talking about a lot today. So we talked about scope, but we're talking a lot about classification. So you're introducing, hopefully, a novel classification of literature on your chosen topic. And that classification helps the reader identify solved and unsolved problems. Right? This is not going to make sense to you right now, unless you've already done it, but it's going to make sense by the end of this lecture. And your surveys always provide a valuable starting point for anybody that's new to the topic or experienced researchers that are trying to find solved and unsolved problems. Right? That's a contribution. Right? Incidentally, you may be working on an updated version of a previous survey. That's fine. Right? If you discover a survey on your chosen topic, I have here, for example, n is greater than 10. It's 10 years old already. You can update it. You can do a new version of it that includes all of the literature since the previous one was published. That's fine. And that is a contribution. And that can be published, by the way. So some surveys get published repeatedly every n years. That's nothing wrong with that. If anybody has any questions or comments, just interrupt anytime. So again, we've shifted from the preparation now to the writing phase of the survey. In the introduction section, which is mostly what we're going to talk about today, the introduction section and the subsections that it contains, you want a generic description of field challenges. That means what are the major challenges that researchers have to overcome in your specific topic that you've chosen, right? What are the unsolved problems? What are the major challenges that everybody has to face and get over, right, to solve their problems? And these are just some generic examples of challenges, right, that can happen in just about every field, right? So a very generic challenge that recurs over and over again is the size and complexity of data. Right, a challenge in lots and lots of fields, right? We have this HPC whales. Anybody heard of HPC whales before? Anyway, lots of people are doing simulation data that result in huge data sets. This is true across all disciplines. So it doesn't really matter which discipline you're in. You're running experiments, you're running studies that involve lots of complex time-dependent data, generally speaking. Did you have a question, Mom? So this is some variant of this challenge can go very, very likely go into your survey. Is anybody here working with data? Yeah, a lot of people are working with data. And the longer you work with it, the more complicated it gets. The longer you collect data, the more complicated it gets. Heterogeneous data is a very common challenge. That means data from multiple sources that doesn't necessarily fit together. Right? You could have text data, you could have numeric data about the same topic, or experiments done somewhere else in the world, in two different locations in the world, or collected by two different groups and you're trying to merge them, for example, or find some relationship between them. Maybe the data that you're studying is time dependent, so it's changing over time. It's a major challenge. Errors and uncertainty associated with measured data and measurement equipment is a major challenge, right? Very generic, very common major challenge. These are just very generic examples to give you the idea of what I'm talking about. You would take these examples and make them more specific to the problem that you're working on, right? You would describe the data that you are working on, right? This is very common. The cost of conducting experiments or expensive equipment is a very common challenge, right? Many fields, many phenomena are difficult to observe directly. So you're trying to study something that can't even be observed directly. That's a major challenge. Anybody here in the biosciences? So in the marine biology, right, that's a very common challenge. You're trying to understand, say, marine wildlife, and you can't observe marine wildlife. It's just not possible, right? So you have to use some indirect methods to try to figure out the behavior. And this is true everywhere. We cannot observe everything, right? Some phenomena are too small to observe directly, for example, in physics, right? Limitations of existing hardware or software, right? All existing hardware and software has its limitations. These present challenges. You wish you had more powerful equipment, more powerful hardware, more powerful software. Very, very easy to describe the limitations of current software. That's very easy. Just talk to a computer scientist. They'll tell you all the pitfalls of the software you're using. Very, very easy. Right, your challenges are described more specifically than these. These are just some generic examples to get you thinking in the right direction that you would customize and tailor. Right? And you would talk about your supervisor with this. But this is something that goes in the introduction of your literature survey. Generic challenges that you are facing, that your researchers in your field are facing, that they're trying to overcome. Right? It's good material. And it's part of the motivation, by the way. Question? What's your name, by the way?
Claire.
Claire.
So
in
this-
which department?
Human geography.
Okay.
So in this case, this is, as you say, the motivation is not already linked with certain authors that I discuss later, or should I already include kind of references? These papers are writing on that specific problem because...
Yes, so right now, that's a very good question. We're talking about the introduction section before the main section of the literature review where you're talking about the individual papers. Does that make sense? So you start discussing individual papers in the next section, for example, section 2. This is still section 1. Any other questions so far? It's exciting, isn't it? I love this topic, by the way. I hope you guys can see that. I love this topic. It's very challenging. But I can tell you, when you've published your first literature survey, it's such a great thing. Such a great thing. You'll be so happy when you publish your first literature survey. You'll be like the man. Sorry to be like, that's not a very politically correct term, but you'll feel good about it. It will be highly cited too. People will appreciate it. I remember that when I first did my first literature survey, I thought, wow, this thing is valuable. It was on my desk, you know, a collection of papers with the summaries and all this stuff. And I was like, this thing is very valuable because it takes a long time to do a literature survey. And I had it on my desk for my entire degree. Like, oh, has that problem been solved yet? Oh, I have this idea. Has it been solved? And I looked at it almost every day going, oh, who solved this problem? And it's a very valuable resource. So let's jump into some examples. The classification, right? This is a huge topic, like I mentioned. We're always talking about the scope, and we're always talking about the classification. These are maybe the two big core challenges for the surveys. What does it mean to classify the literature? It means to try to develop categories that the literature fits into. A series of buckets. Like this paper addresses this topic. This paper addresses this topic, and so on. Here's an example from a survey paper called Visualization for the Physical Sciences. Right, you can download this. This is available on my webpage. It's an interesting literature survey, and each one of these boxes is a previously published paper, right? That we cite and refer to in section 2, right? This is how we classified the literature for visualization in the physical sciences. So we have a two-dimensional table, and across the top are the different subdisciplines in the physical sciences: astronomy, chemistry, earth science, and physics. So the papers fall into one of those categories. And then along the y-axis are the spatial dimensionality. So these are all two-dimensional visualizations. They reside in a plane. And these are all volumetric or three-dimensional visualizations. So this line, 2D, below is 3D. And then this is divided again, the 2D and 3D, into static and time dependent. So I know that this is a paper, it's an astronomy paper, it's two-dimensional visualizations, and it's not time dependent, it's static, one time step. Right? I learn a lot about that paper without looking at it. I already learned, so I learned a lot, right? Isn't it interesting? We didn't find any chemistry papers that are static or time dependent that use 2D visualizations. But we found lots that use 3D visualizations. And so on. So in our survey of visualization for the physical sciences, these are the papers we found. And we put them all in the different categories. They fit in one of these buckets, right? Each square on the table is a bucket, or each rectangle, right? And I can see, oh my gosh, look at all the papers in here. This is very crowded. A lot of work has been done in physics. Oh my gosh, a lot of work has been done in physics using 3D visualization of time-dependent data. That's where most of the work has been done. So if I'm looking for unsolved problems, I'm going to have more trouble contributing here. I probably want to look somewhere else, like here or here, to contribute to visualization for physics, maybe. Right, so this is a solved more. This isn't necessarily a solved problem, but it's more likely to be solved. Right? This is clearly an unsolved problem here because there are no papers. It's an unsolved problem. And there's a color in there, by the way. The color is a third dimension. It's not critically important, but the colors mean things like. This color means multi-field visualization. This one means the graphics, hardware, feature detection, and so on. It's not critically important. So I just thought I would throw that example in there before discussing more about this classification business. Deriving a literature classification is one of the major challenges in your literature survey, right? A classification categorizes each research paper such that similar papers fall into the same group. Closely related papers fall into the same group. And then the question is how? How to do that? How do we derive groups, categories, and dimensions for your classification? This requires some thought. And in my case, it requires sometimes it requires months of discussion because it is challenging. Yeah. Here are some very rough guidelines though that are very applicable in general. Categories are often based on subtopics, reoccurring themes, data, or metadata attributes. These are very common classifications. So you'll find groups of papers that address the same subtopic, a whole group of them, and those naturally fit together as a cluster. And then you'll discover, oh, there is more than one subtopic. So I have multiple subtopics. And these two are very connected, the reoccurring themes. So look for reoccurring themes over and over again in some of the papers. The data that's involved in the experiment itself can be used to classify the paper. What kind of data, the data characteristics. Is it static data? Is it time-dependent data? Is it high-resolution data, low-resolution data, and so on? What are some of the themes and subtopics that reoccur over and over again? These can form natural subject-based clusters. And you might be thinking, well, that's how am I supposed to identify those? You'll see those when you're reading the papers. They will appear. But there is a tool, I think it's on the next slide, that to help. It's called Surveys. We have a Surveys expert in the audience, by the way. Liam can answer all of your Surveys questions. What are some of the characteristics that must, if not all, papers you search have in common? Right, so that's a basis for one of your classifications. Data characteristics are a very common categorization dimension. And so that previous example fits that, right? These are data characteristics on the y-axis, and those are subject categories on the x-axis. This is a snapshot, by the way, from a tool called Surveys, right? And you can use, this is a free tool you can download and put your papers in it, and it provides you with these natural topic clusters that reoccur over and over again. It will generate a graph of publications versus year, and you'll be able to explore the keywords and the different subjects and derive subject classifications. Right? That's just a screenshot from that. That could be its own lecture, I think, just a Surveys lecture. But it's a tool that none of you know about except for Liam. Did you know about it though, Dylan, right? No, you didn't know about? Okay, so even Dylan didn't know. Mohammed? No, not yet? Okay, so only Liam knows about this tool. So now everybody knows that a tool exists to help you with that, right? So don't be afraid to check it out. Probably a lot of you didn't know that tools for this exist at all. This isn't the only tool. There are literature survey tools that you can use to help you. So they exist. This is not the only one, right? But you can check out this one because it's one of the recent ones. But in the related work section of this paper, it's going to talk about other tools. Anyway, we won't go into lots of detail about this because it's really its own lecture. Here's another example. We're going to go through lots of a few examples. I see that The time is running short. So here we have another example classification table. It has on the y-axis steady state data, unsteady data, that's time independent versus time dependent data. And then we have different topics along the x-axis, like two-dimensional curves, surfaces, 3D particle tracing. There's a line here, essentially 3D rendering and placement, surfaces and volumes. So that doesn't really have to make a lot of sense to everybody. The point is, it's another example of one of these classifications right there. Actually, it's data being used on both the x-axis and the y-axis data characteristics. It's not just the y-axis. And at the end of this lecture, by the way, there's a list of references, and it's all the surveys that we're pulling our examples from. So if you actually wanted to see what this survey looked like, you can look at the references, and all the surveys are online. Here's one from Bioscience, a classification. Right, examples of the literature reporting effects of roads and traffic on wildlife. And the categories are not mutually exclusive, it says. So this is all literature that examines the impact of traffic and roads on wildlife, and they're put into different categories, like loss of habitat and changes in biotic communities, linear habitats, affecting behavior of mammals, affecting fish and birds and so on. Right? Fascinating topic, by the way. Absolutely fascinating. I don't know, like, since I've been a child, I've noticed, if you put a big highway somewhere, it divides the world of mammals into two, right? A mammal cannot cross a large highway. Right, they die if they cross it. So for a mammal, if you build a big highway, you're dividing the world in half. They can't cross it. So it has a huge impact on wildlife. Here's another example from Bioscience. Right, we have a list of papers on the x-axis, a type of study on the another axis, and the human health aspect. A description of human health aspects in the third column, right? So this is trying to come up with an overview table. Studies exploring the contributions of green spaces in nature to human health, right? So that's another kind of overview table. Here's one from geography. And the papers are grouped by so-called priorities, right? Major priorities in the geographic information science research, right? These are data-centric priorities. These are research priorities, strategic priorities, research challenges, emerging themes. So you can see, looking at other surveys in your field, how informative that is. So if I was looking for unsolved problems in geography, if I was doing geographic information science, I would definitely be looking at this survey, right? Not all literature surveys have classification tables, unfortunately. Only the best surveys have classification tables. You can find plenty of research literature surveys that have no classification table at all. You can find some, unfortunately, that are just texts from the beginning to the end. But that's not very nice, is it? Because that implies you're supposed to read the whole thing from start to finish, and you might not have a clear picture of what the solved and unsolved problems are. It is possible to find those. It's very nice to have an overview table. Some literature surveys have metadata, so that's not necessarily a classification table, but they try to generate some metadata. Like this is another one from geography, a concordance. So There's a concordance of the literature. This is the GI Science Conference from 2002. This is the GI Science Conference from 2004. And it's a concordance of all the papers, right? The major themes. So we can see the biggest theme here was information and spatial data was a huge theme this year. Analysis was a huge theme in 2006 and so on. And then, but I see that data is always reoccurring, right, in these. So I can see, data is the major theme from geoscience from the years 2002 to 2014 with a metadata. Metadata, everybody heard that term before? Data about data. The best surveys have metadata about the literature. Here's an example of physics, an example that just tries to classify motion, different motion, and put all the papers in a relevant category related to the kind of motion that's being addressed. That's very, very small font. A gallery of images related to collective behavior. Among others, it illustrates the possible existence of very general behavioral patterns. So that's an interesting physics classification or example of metadata. Here's another one from physics. This is really cool, by the way. This is in the most cited physics paper in the entire universe. Pretty cool. That amazing survey with 1 million co-authors, and it's 1 million pages long. It's the survey of particle physics, and it has all the identified particles, even ones that haven't been experimentally discovered yet. And the accuracy, each one of these is the accuracy of measuring the particle's mass, for example, and other properties over the years. So you can see from 1970 to 2010. This is uncertainty, right? So the uncertainty gets narrower and narrower as the experiments become more and more accurate over the years. That's a nice metadata example that's really nice for a survey, right? Mathematics, for me, mathematics is the most challenging to do a literature survey in because it's difficult to find mathematics surveys that have nice classification tables in them. This is one mathematics survey that has some metadata, and it has some information about solved and unsolved problems. The state of the art of if the surface is the sphere or the torus can be explained by the following table. So it's easy to find math survey, literature surveys that have no metadata and no pictures and no classification table. Those are difficult. If anybody finds a really good mathematics literature survey paper with a nice classification table, please let me know. I'd love to see it. Here's another one from computer science. This is a hierarchy visualization. This is a research paper, a famous research paper, and these are all research papers that were published as a result of this one, right? And they have certain properties, and those properties are indicated by these glyphs, right? So you can get a complete overview, like 2D, 2.5D, 3D, unsteady, and so on. You can get a complete overview of all the papers published on this topic and how they're related to each other, just in a nice figure, right? And that was, so far I've been talking about the section 1. This is just an example of section 2. The section 2 is the includes descriptions of the papers according to our previous lecture on how to read a scientific paper. And now they're in categories. They're grouped together, they fit naturally together, and they flow. So wrapping up, this is what your survey could look like in the beginning, the introduction section. This is a generic outline of what a section it could look like. right? You have section 1, which is introduction and motivation. It includes a description of your contributions. You have a subsection on challenges. You have a subsection on scope, search methodology, classification of literature, and the organization of the survey. You might have a section called metadata, and then section 2 is where the paper summaries go. That makes sense, hopefully. It's a lot of information, isn't it? A lot. Big topic. Very exciting, too. So these are the survey papers that we referenced, and you can find them all online. Any questions or concerns, comments? If you do have questions about literature surveys, I'm happy to try to answer them, anytime. It doesn't have to be during the class. Happy Thursday.